Hello and welcome to another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 11cc, Lesson 9 on quartiles. All right, so we've learned about statistical questions in the last lesson, or we reviewed them from Math 6. We also reviewed a bunch of different statistical measures, and those are just simply numbers that we use to answer statistical questions. Things like the mode, the mean, the median, the minimum, the maximum, the range. All of these things will help us answer statistical questions, which really are questions that don't have a single answer. Like, what is the average salary of a lawyer? Well, actually, that's not a statistical question. A statistical question would be, how much do lawyers get paid, right? There's some average, which is the mean. There's some median salary for lawyers. There's probably some minimum salary, probably $0. There's probably some maximum salary I don't even want to think about, right? So all of these help us answer a statistical question like, how much money do lawyers get paid? Well, quartiles are a brand new type of statistical measure that we're going to introduce today. So let's get right into it in the first exercise. All right, here we go. Remember that the median of a data set gives us the number that's in the middle of the data set when the data values are arranged in order. So let's play around with the median a little bit in exercise number 1. A class has a contest to see how many push-ups kids can do in a row. 11 kids participate and the results are shown below in order. All right, letter A, very simple. What is the range of this data set? All right, well, why don't you go ahead and pause the video really quickly, and actually, why don't you answer both question A, which is the range of the data set, and question B, which is the median of the data set. Both of those are review from the last lesson and from Math 6, so pause the video now and see what you can remember. All right, well, first, the range, right? The range is a measure of how spread out the data is, and it's a very simple formula. The range is equal to the maximum value minus the minimum value, which in this case is 21 push-ups minus 6 push-ups, or 15 push-ups. All right, 21 push-ups is a lot. Anyway, what is the median of this data set? Well, remember, the median is the number right in the middle. There are 11 kids. Okay, so my little trick at least is I'm going to take, if the number of data points is odd, I'm going to subtract 1, get 10. I'm going to do 10 divided by 2 and get 5, and then I'm going to count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and that is going to be my median. So my median was 14 push-ups, right? The median is what's known as a measure of center, which really makes a lot of sense given that it's the number in the center of the data set. But really, if you were trying to answer the question, how many push-ups can middle school students do, and you went out and you collected this data set, you might say, well, the median number of push-ups was 14, right? Meaning that, the typical student could do 14 push-ups in a row. Now let's take a look, though, and bring our data set up just a little bit. Let's take a look at letter C. If the median was excluded, what value would be the median of the lower half of the data set? Circle it. So let's talk about this. Let's just say that the median wasn't even here. And we looked at the lower half of the data set, right, which has 1, 2, 3, 4, 5 values in it. What would be its median? Well, the median of the lower half of the data set would be that 8, right? Because there would be 2 below it and there would be 2 above it. So it would be 8. And likewise, letter D, if the median was excluded, what value would be the median of the upper half of the data? Circle it. Well, again, easy enough. We've got, these 5 data points. So the one that's right in the middle would be the 17, right? So that would be the median of the upper half of the data set. Now, think about this for a moment, right? The median really divides the lower 50% of the data set from the upper half of the data set. What we just did is we just found 2 values that then further divide into quarters, right? Literally, right? Then we've got the lowest 25%, the highest 25%, and in between these two, we've got sort of the middle of the data set, the middle 50%. These values in C and D represent what we call the first and the third quartiles. And if the word quartile reminds you of the word quarter, that is awesome, because that's exactly what quartiles do. They quarter up the data set along with the median, right? So literally, these things kind of divide the data set up into 4 sort of equal-sized groups, all right? And that's good, right? So the median is like, okay, upper half, lower half. Then the 2 quartiles are, well, lowest quarter, highest quarter, and the middle half in between. And that's all quartiles are. All they are is the median of the lower half and the upper half of the data set. So if you can find a median, you can find a quartile. It's that simple. In fact, I kind of wish we had referred to the mean, not the mean, the median as the second quartile. They don't, they just refer to it as the median, but one could think of it as the second quartile. The first quartile is the median of the lower half of the data set. We symbolize it with a big Q and a little 1. And the third quartile is the median of the upper half of the data set. It's symbolized by a big Q and a little 3, all right? And that's it. That's all quartiles are. And we're going to be working with finding them today and kind of interpreting them a little bit, and also learning about one more measure, one more statistical measure, but we'll get to that towards the end of the lesson. So let's do a little more work with these quartiles. Let's see how it's done. Exercise number 2. Michaela was conducting a science experiment where she grew corn plants for a month. She grew 12 plants and recorded their growth in centimeters. Letter A. If this data set was broken into quarters, how many data points would be in each quarter? Well, that's pretty easy. Now, by the way, in statistics, there's lots of symbols that are used for various measures. And one of the simplest statistical measures is actually how many data points we have in the data set. And that's almost always represented by our favorite variable, the letter n. Not the letter x, but the letter n. So in our case, right, our data set has 12 values. So if we divided that by 4, there would be 3 values in each one of our quarters. That's simple. Letter B. Draw lines in between values to show the different quarters. All right, so literally, right, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Right? So literally we have the first quarter, the second quarter, the third quarter, the fourth quarter. Letter C, state the values of the first quartile, the median, and the third quartile. Well, by the way, these lines really represent where the first quartile, the median, and the third quartile would be. So the first quartile, Q1, would be the average of the two 20s, which is just 20. But, just in case that's not painfully obvious, Q1 would literally be 20 plus 20 divided by 2, which is 20. Now, you don't really have to show that, okay, but just to be clear, that's the way that we dealt with medians when there was an even number of data values. Same thing for the median, right? The median would be right here. So the median would be literally 26 plus 28 divided by 2, but that's going to give us 27, right? The number that's right in the middle. And then maybe the one that's most challenging, Q3, that's going to be the average of the 31 and the 35. So we do that, and the number that's right in between those is 33. So our first quartile is 20, our median is 27, and our third quartile is 33. All right, simple enough. Now this particular exercise worked out really nice because 12 is really nicely divisible by 4, right? We can easily quarter up the data set. Most of the time, it doesn't work that nicely. In fact, I'd say 3 out of 4 times, we're not going to have a multiple of 4, right, that we can divide by 4. So let's see what we do if it's not that easy. Finding quartile values can be a bit confusing if the median is part of the data set, which happens when the data set, right, has an odd number of values. So there are rules, and none of us like to memorize rules, so try to make the most sense of these rules that you can. Let's talk about finding quartiles, right? So finding quartiles depends on whether the data set has an even or an odd number of data values. If it's got an even number of data values, we simply find the medians of the lower half and the upper half of the data. We just take the data set and we go, well, all right, since there's an even number, let's say there were 18. We'd say, well, there's 9 in the bottom half, there's 9 in the upper half, so in the lower half where there's 9, I'd find its median. In the upper half, there's 9. I'd find its median, and then I'd go merrily on my way. It's when there's an odd number that it's more confusing, because when there's an odd number, obviously there isn't an upper half and lower half, because there's an odd number of data points. In that case, what we do is we find the median, and then we kind of throw it out, right? We don't throw it out as in like there is no median, but we don't then consider it when we think about the quartiles. So let's say that there were 21 data points, right? That would mean there'd be a lower 10, an upper 10, and then one right in the middle, right? The 11th data point. So what we do is we'd say, okay, that 11th data point, that's our median. And then we wouldn't consider it when we think about the upper half and the lower half. We'd say, all right, well, for the upper half of the data, we've got these 10 values. And for the lower half of the data, we've got these 10 values, and we're going to find their medians. I know that can sound rather confusing, so let's just get into it and do some of them. Exercise number 3. For each data set, find the quartiles and the median. All right, so let me bring this up a bit. We've got 4 of these to go through. The first thing you always want to do is just figure out how many data points there are. So in letter A, we've got 1, 2, 3, 4, 5, 6, 7. All right, we have 7 data points. All right, now what that's going to mean, right? We always want to find the median first. Always, always, always find the median first. So, right, if there's 7 data points, that means, right, there's 3 and 3, and our median is going to be equal to 20. Now the whole point of finding now the quartiles is that I don't want to include that 20 in the lower half or in the upper half, because it's really not part of either the lower half or the upper half. I want to just now consider these 3 when finding Q1. That's all I want to do. So, since there's only 3 of them, the one that's right in the middle, the first quartile, is going to be 14. All right? Then, when I consider sort of the half of the data that's above the median, well, that's again pretty easy. Since there's only 3 of them, Q3, the one right in the middle, is going to be 24. It just wouldn't make sense to take the median and include it in either the upper half or the lower half, because it's right in the middle. So we just exclude the median, and then we find the medians of the upper half and the lower half. It's that simple. Let's take a look at letter B. Here I've got 1, 2, 3, 4, 5, 6, 7, 8 values. 8 values. All right, so n is equal to 8, which is really nice, right? Because that means if I divide it into the upper 4 and the lower 4, right, then I can first find the median, right? The median is going to be the average of the 38 and the 40. Simple enough. So let me move this n equals 8 somewhere. Oh, wow, now you're not going to all stay together. One little symbol at a time. Hopefully I get the whole 8. There we go. Right, so the median is going to be the average of that 38 and 40. Now again, the median is always the number that lies halfway between those two, so if it's easy enough for you to just immediately say the median is 39, awesome. Now in this case, I don't need to throw the median away and in order to think about the lower half and the upper half, because the median isn't part of the data set. Now I can literally look at the lower half and say, all right, well, what would be the median of this lower half? Well, that would lie right here, right? And Q1 would end up being the average of those two 34s, but of course that would just be 34, right? Likewise, Q3, right, would be right here between the 45 and the 49, and that one might take a little bit more work, right? We would get 45 plus 49 divided by 2, and that would be 47. All right, so I've got Q1, the median, and Q3, right? Always. And again, it just slices this data set up into 2, 2, 2, 2, right? It quarters it. All right, that one's pretty easy because literally 8, right, is easily divisible by 4, so I should have 2 values in each quarter. Let's take a look at letter C and letter D, which have slightly bigger data sets. Let's take a look at C. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. One more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. I always want to make sure I've got the right number. So n equals 10. what I'd like you to do is pause the video now and see if you can figure out the median, the first quartile, and the third quartile of this data set. All right, well, one of the nice things about n equals 10, right, a nice even number, is it's going to divide my data set up into the upper 5, right, and the lower 5. Okay, so simple enough, right? Nice even numbers. So right in between them is going to be the median. And again, here it's easy enough to think to myself, all right, the number that's right between 47 and 48 is going to be 47.5. Now, to make our lives even easier though, right, unlike exercise B, the lower half and the upper half now have an odd number of values. So we can literally just look at them and say, oh, well, in this data set, the number right in the middle is 43. And in this upper half of the data set, the number right in the middle is 51. And so our first quartile value is 43, and our third quartile value is 51. Simple as that. Let's take a look at one last one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 values. Let's just move this over here. 13 values. What I'd like you to do, pause the video, see if you can identify the median and the first quartile and the third quartile. All right, so 13 is a little bit rougher when it comes to the actual median, right? Because I got to think about, well, if I took away 1, I'd have 12, and then if I did 12 divided by 2, that's not a division symbol, I'd get 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? So I've got my sort of lower 6 and my upper 6, okay? Which means that my median is sitting right there at 11, okay? So simple enough, right? Lower 6, upper 6, median. But now I don't want to include that median in either the lower half or the upper half. It would seem a little bit unfair, right? So what I'll now do is to find my Q1, my first quartile. By the way, that's also known as the lower quartile. Q3 is often known as the upper quartile. But if I look at the lower half of the data set, there's 6 data points, which means that the median will lie right here, right? Right between that 5 and that 6, so that I have 1, 2, 3 values there and 1, 2, 3 values there. Remember, I'm kind of eliminating the median in this case. So my lower quartile, or my first quartile, is going to be halfway between 5 and 6, which will be 5.5. Very similar in the upper half of the data, right? Since I've got 6 values, the one that's going to be right in the middle of those 6 values will be between the third one and the fourth one, a little tongue-tied there. And so my third quartile, also known as the upper quartile value, will be 20.5. Now, before we move away from this and we look at one last statistical measure, just to kind of reiterate the idea of the quartiles. Remember, all of these statistical measures are out there in order to help us answer statistical questions. So if we go back to that example of like, how much money do lawyers make, right? It might be interesting to know the first quartile and the third quartile value. Because if you knew the first quartile value, let's say I said, I went out and I surveyed 100 lawyers and asked them what their salaries were. And I said, well, the first quartile value is $72,000 a year. You would know, wow, I mean, like 75% of people, 75% of lawyers are going to make more than that. 25% are going to make less than that, right? Now, if I said, well, the third quartile value for lawyers was, I don't know, $180,000 a year, you'd say, wow, that's kind of that number that like 25% of lawyers actually make more than $180,000 a year. So that's the idea, right? Just like the median, what the quartiles do is they give us some like almost stopping points in a data set, right? They give us some sense of like where different values are. So, you got your minimum, Then maybe like, where are we when we're like through 25% of the data? Where are we when we're through 50% of the data? That's the median. Where are we when we're through 75% of the data? That's the upper quartile or the third quartile. And then, the maximum would be, like, everything is, at or below this kind of thing. So one last statistical measure that we're going to look in this lesson is another measure of what's called spread or variation, right? And it's what's called the interquartile range. The interquartile range. So we know what the range is. The range is the maximum value minus the minimum value. And the bigger the range is, the more spread out the data set is. But we can also look at the third quartile value minus the first quartile value. And that's what we're going to call the interquartile range. So let's do that in exercise number 4. Let's take a look at it. The ages of 14 people who work at a restaurant are shown below. Letter A, find the first and third quartiles. All right, so what I'd like you to do is pause the video now, take this data set that has 14 people in it, and figure out what Q1 is, the lower quartile, and Q3, the upper quartile, also known as the first and the third quartiles. Go ahead and do that. Take a few minutes. Well, my data set has an even number in it, 14. So if I divide that by 2, I get 7, right? And I'll have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so that's the lower 7, the lower half, and the upper half. Now, I was never asked to find the median. If I was, it would be right there. So it'd be the average of 23 and 23, which would be 23, but whatever. Now what's really nice is that the lower half has 7 values in it, which means that the median of this lower half is going to be the 4th value, or 19, right? Because there's 3 values then below it, 3 values above it. If I look at my upper half, same deal. I don't even want to think about these things down here. I'm going to go to the 4th value up there, and that's going to be 28, right? So we can write those down. Our first quartile value is going to be 19, and our third quartile value is going to be 28. All right, as simple as that. Now, letter B, the interquartile range. Man, that sounds technical, the interquartile range. In fact, this is such a common statistical measure that people often abbreviate it by IQR. They'll even say, hey, what's the IQR of this data set? If you want to sound really geeky and smart, refer to it as the IQR. And the IQR, the interquartile range, is like the range, except instead of max minus min, it's the upper quartile minus the lower quartile. So it's 28 minus 19, which is going to be 9. And that's actually 9 years, right? Because these are all ages. So the interquartile range is 9 years. Think about what the actual range is. The range would be 48 minus 17. That would be 31 years, right? The range is quite large, 31 years, because we have, maybe this is some senior manager. Maybe it's the owner of the restaurant who's 48 years old. And then maybe you have somebody who just joined the restaurant. Maybe they're a waiter or a bus person or something like that, right? And they're, only 17 years old. The interquartile range is much, much smaller. Now let's take a look at letter C. What does the interquartile range represent about the data set? Well, again, think about this. You got your min, you got your max, you got your median, and then you've got this data value and this data value. In theory, 25% of the data should lie here, 25% of the data should lie here, 25% should lie here, and 25% should lie here. So between Q1 and Q3, which is what we're really dealing with right here, we're talking about the middle 50% of the data. In fact, let me kind of really write that up here, right? This is the middle half of the data. And so what the interquartile range really does is it tells us how spread out the middle half of the data is. And we'll talk more and more as this unit goes on about why the interquartile range actually might be a little bit of a better measurement of the spread of a data set than the range. And that really gets into like the idea that you could have what are known as outliers in a data set. We'll talk about those significantly in another couple lessons. For right now, all the interquartile range says is how spread out the middle 50% is. So overall, right, the spread on this thing is 31 years. That's the overall range, 31 years, 48 minus 17. But the spread of the middle 50% of the data is a little bit less than a decade, right? It's only 9 years. So the difference between somebody who's sort of at the third quartile and somebody who's at the first quartile is not really all that great compared to somebody who's at the maximum versus somebody who's at the minimum. All right, let's wrap this up. So today we got into brand new statistical measures that you probably didn't see in Math 6, right? And those were the quartiles. And the quartiles, the first quartile and the third quartile, kind of cut off the lowest quarter of the data and the highest quarter of the data. All right, the median, right, divides sort of the lowest half compared to the upper half. Now, finding the quartiles, although it can be a bit confusing, is really as simple as finding the median. You're really just finding the median of the lower half of the data set and the median of the upper half of the data set. The thing that can be confusing is, of course, what happens if the median is actually part of the data set, if you have an odd number of values. And in that case, you just don't include the median in either the upper half or the lower half, and you still find the medians of the upper half and the lower half in the same way. All right, we'll work a ton more with quartiles in the next lesson as we introduce a new graphical display of data called the box plot. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.